Okay, so we had this example of solving a differential equation with a matrix. The eigenvalues are positive and the solutions grow. If we plot the solution for t between 0 and 2, we get x1 and x2 plotted on these axes, and of course it grows quite quickly because of the exponentials. So here's another example. A was 1, 4, 1, 1. The eigenvalues are 3 and minus 1, and that was the matrix P that we got. And we're starting with initial conditions 1, minus 1, and then we're going to restart it with 2, 1. So we can just work out the answers. Y is P inverse X. D is the matrix 3 minus 1. And so the solution, when is a decoupled system, y dot x dy, the solutions are y0 e to the 3t and y0, y20 e to the minus t. The eigenvalues are positive and negative, so this part's decaying and this part's increasing. So it kind of depends how much of it you have in the initial conditions. If you don't have any y1 in initial conditions, then you'll get the decaying behaviour. To get back to x, we have to multiply this by p. So for the first case, we put in x0. X0 is 1 minus 1. And so we multiply that x0 by p inverse, we get this. And if we multiply the other x0 in the case B by p inverse, we get 0, 1. And you notice in this case that's only the second one which is decaying. So the solutions are, in the first case, we've got this growing exponential and decaying one. In this case, because we started off with y at time 0 as being only 0, 1, only the second eigenvector, this is decaying. So writing the answer back in terms of x means multiplying by p, and so the solution for x in the first case, it's got both components have a positive growing exponential, and this eventually decays as t increases. Whereas for the second one, we've arranged for there to be none of the first eigenvalue, and so we only get a decaying exponential, and so the solution has only got negative exponentials with negative powers in, and so they're decaying. It's only kind of an exceptional thing. You think if you were, trying to manipulate it so that it did have a decaying solution rather, you have to hit that initial condition exactly right to get no component of that first eigenvector in it.